Okay, so let's talk about farming. So, in the previous chapters, we've been talking about population growth. We looked at the factors behind it, what it contributes to exponential growth, and then the leveling off, that logistic growth. And a lot of it comes back to availability of resources. In the case of humans, food. Can we feed everybody? So, in this chapter, we're going to talk about farming, conventional, and different sustainable practices that we're doing. I want you guys to be able to evaluate the pros and cons of agriculture. There's a lot of great things, but there's also some very, very challenging things that we need to be aware of and be very, very conscious of if we're going to try to do this long term. So that's what we're going to explore throughout this chapter is farming, the different methods and things under cultivation, and then in pros and cons. So when we have these conversations with people in the agricultural community, we can understand their perspective, which is very, very important. But then we can also propose or recommend different ideas. What about this idea? What about that idea? As things that will help them be sustainable in the long term. Because most people involved in agriculture are looking for long term, not just how much can I make today. So let's start with agriculture. Agriculture is a cultivation of land, breeding of plants and animals to provide products for human benefit. So what are we doing here? So think about all the different things we've domesticated, all the different animals and plants. We often focus on, with agriculture, we talk about crops, corn and beans. But we're going to expand that out. We're going to talk about other things that have been domesticated. Chickens and bees and rabbits and horses and sheep and alpaca and etc. Those play a big role in feeding the human population. There's a lot of products we derive from those other non-plant-based resources. So we want to, again, look at agriculture in the larger perspective, not just focus on just plants. And especially when we talk about plants, not just corn and beans, because that's primarily what we do in the Midwest, but all the different plant products out there. Excuse me. So, all right. So let's take a look at agriculture. To do any variation of agriculture, you generally need soil. You got to have soil, ground, to grow crops to provide food for your animals. So, again, if I'm raising dairy, I still need feed for my cows. I need corn, I need beans, I need wheat, hay, alfalfa, etc. So as we look at soil, soil is formed through the weathering of rocks and then the accumulation of organic material. It takes thousands and thousands of years to create soil. We have things like fungi, bacteria, all those things we call decomposers and detritivores. They play a role in creating the soil, and then the soil accumulates over time. The challenge is the formation rates of soil is very, very slow. It's about 1 millimeter per year. So if you're looking at, oh wow, I have a spot I'm going to make a garden per year. Let me get the year in here. And I'm going to let nature do all the work. It's going to take quite a while to get your soil built up. We usually speed up the process by putting manure on there, fertilizer, things like that. The challenge is most modern agriculture and most farming techniques, large-scale farming techniques, deplete soil through erosion and the removal of the organic material. So, you're making 1 millimeter of soil a year, but erosion rates can be up to 25 millimeters per year. So you're definitely going in the negative. So I lost 25 millimeters of soil this year, and I only gained one back. couple years, you're in a significant deficit when you talk about your soil and soil quality, the nutrients available, things like that. So as we look at soil, soil is composed of 6 different components. So there's a picture there, cross section, digging a hole down through the ground. And there's 6 different main components to making up soil. So we start with sand and gravel as one component. We have silt and clay as a second component. We have dead organic matter as a third component. We have what's called the soil fauna and flora. So what little critters are living in the soil? Different invertebrates, worms, insects, bacteria, fungi, all that. What different types of plants are growing in there, lichens, things of that nature. That helps make soil. We also need water, and this may sound a little ironic or weird or unexpected, but you need air. You need oxygen. You need oxygen in there for your soil fauna. So those worms, they need oxygen. The root system of plants needs oxygen. If a field gets flooded and you can't get oxygen down there, it kills everything. So you take all these different components, put them together to make soil, and then you have the basic component that you need to grow crops. So we can produce plants, produce corn and beans and wheat and peaches and strawberries and all the stuff we like to eat in the plant world. But what we're going to see is then that plant product often is used to go to the next level in the food chain. Well, I'm raising cattle to sell to restaurants for beef. I'm raising pigs, I'm raising chickens, and so on. It all starts at the soil, and then the soil determines the producer base, producer usually being your corn and beans and wheat, etc. And then that moving to the herbivore base, and then that moving to us. So soil is, again, incredibly important for the entire spectrum of the agricultural industry. So these 6 components are there. Now, depending upon how much you have of each, your ratios, that's what will determine the quality of your soil and your soil texture. So soil texture is the most important characteristic of the soil. What is the ratio or the amount of sand, silt, and clay? So I want to highlight those. The sand, silt, and clay ratio, that's going to look terrible, so I'm going to take it off so you guys can actually see the words. But pay attention, that's a very important component. Big hint. How about we change the font color? The sand, silt, and clay, that's incredibly important. You don't want solid clay because then it packs together and it creates what's called deadpan, and water and things don't move through it. You don't want complete sand because then water just goes whoop, straight through it. You don't want just silt. You want this mixture, and you want it in the right ratio that will give you ideal soil. So when you hear about loam soil, this is a mixture, let me back it up, the ideal mixture of sand. Oh, that should be sand. Sand, silt, and clay to give you highly productive soil. So farming soils, the stuff here on the left, that soil right there in the circle, that is beautiful black dirt. That is loam. You're going to get a lot of productivity out of that type of soil. You're going to get higher crop yields. You'll get more bushels per acre, healthier plants. Good quality farm soil is going to be this loam. It's going to cost a lot more because your yields are much higher. Now, if you have clay, the stuff over here on the right, that red kind of clay, it's stuff you could put some water in, mix it together, and create a clay ball out of. That stuff's not so good. Hard to grow plants in that. They don't produce as much. The yields are lower. So loam, again, is that ideal soil for the agricultural world. So when you look at farm fields and farmland for sale, and somebody says, hey, I want $11,000 an acre. What kind of soil? If you have loam and it's flat, easy to get to, you're probably going to get 11,000, 12,000 an acre. If it's mostly clay, if it's sloped, you might get 6,000 an acre. Huge difference in value based on the quality of the soil. So to identify soil, we use a soil texture pyramid, and we look at the ratios. So you figure out what is my percentage of clay over on this angle here. Say I'm at 80% clay, so we're right about here. And then I look at my percentage of sand. Maybe I have 50% sand. I can draw my line up from the sand, draw my line over from the clay, and then I have 10% silt. So then I come down on the angle here, and I look, oh, actually this one should go that angle. I look at the intersection, and right there is the quality of my soil. Not so good. Not the ideal stuff. Let's see, let's find some good loam, sandy loam. Here's our main loam. Let me clear our lines out so we can see this easier. Okay, so now you go back to your same field, or actually it would be a different field, and you say, hey, let's check out this field's got loam right there, and you start looking at the percentage of silt in it, probably about 30%. You do the percentage of clay, probably about 60, 65%, and then you look at the percentage of sand, and probably about 40%. That's giving you your loam soil. And there's a range of sands, silt, clay that will still all give you loam. But again, that is your ideal, beautiful, beautiful soil. So grasslands, that's Illinois, or was Illinois. Grasslands are a lot of loam soil. Here is a cross section of Illinois grasslands. You dig down 4 or 5 feet, and this is your soil profile. It's black dirt for the most part, depending on where you're at. Again, you get closer to area that was a lot of trees, that was mostly forest, it's not as good. You get a floodplain, beautiful soil there because of all the silt coming in from the river when it would flood. Not ideal for crops, but the nutrients getting dropped by the river, wonderful, wonderful soil there. What used to be prairie, mostly loam, that beautiful soil. That's why those environments, those ecosystems have been tilled and turned into agricultural fields. Compared to the soil on the right, this is a soil profile. So you're digging down about 2-3 feet in tropical soil. Terrible, terrible soil. Absolutely terrible soil. Red, iron. It's iron rich. It's a lot of clay. Terrible soil here when we look at tropical soils. Mostly iron. This is going to be really bad with their handwriting, so I apologize. And clay, nutrient poor. Tropical soils have very little nutrients in them. And that is such an ironic thing to think about when you're looking at the tropical environment. All these gigantic trees and an incredible producer base, but the soil is just terrible. All the nutrients are sucked up into the plant life. So there's nothing left to really sit in the soil and be held in the soil. So it's why the tropics are horrible for agriculture. It's just terrible to try to raise crops in the tropics because there's such low nutrient levels in the soil. So what they often do in the tropics is they will add lime to the soil to try to enhance and improve the soil quality. Lime and then lots of fertilizer. So a lot of fertilizer, mostly in the form of nitrogen, gets added into the tropical soil. Then the problem is runoff washes it away, and now we get back to eutrophication issues, especially from tropical farming. So in our next lecture, we'll take a look at the soil fauna.